What's up, guys? Mr. G here with our fourth lesson in our mini division unit. For today's lesson, you'll need, drumroll please, a paper, otherwise known as a papel, and a pencil, otherwise known as a lápiz. Again, our learning targets are: I can find quotients with remainders of division problems with single-digit divisors and dividends to the thousands place. How? How we do that? How we've been learning to do that, which many of you have done an exceptional job showing and doing, finding those solutions, is I can determine quotients with remainders using standard form or partial quotient strategy. Again, there is many ways you can do math. Today we're going to look at those especially tough divisors: 6, 7, 8, and 9. So, some of those factors, some of those divisors that sometimes we're feeling a little unsure about. So in our I do and our we do, pay particular attention to those times where I use the tape measure to help us find out those tough quotients when we're using inverse operations. All right, guys, let's get started. As always, we start with our I do. So find a quiet place, get in a position where you're ready to either learn new skills or review everything that we continue to learn. All right, guys, starting off with standard form. When I'm attempting a problem and I'm using a strategy that involves standard form, or I'm using standard form, I always want to put my steps down somewhere for reference. We are dividing, multiplying, subtracting, bringing it on down, and bringing it on back. For this case of this I do, I put down my tape diagram. That's a strategy we're also going to be utilizing today. So with our inverse operations, when we're using our mental math thinking, we can also use the tape measure either in our brains, or we can literally do it on the side. So we don't have a multiplication chart available, we don't feel like using one, we have a new strategy. Let's visit it. So our problem, 4,867 divided by 6. First step is on dividing. So I'm thinking, can 4 be divided by 6? Can 6 go into 4? It absolutely cannot. I need to go to the next place value. So I'm still dividing. Can 48 be divided by 6? Absolutely can. So in my brain, I'm thinking 6 times a number equals 48. So we're working with a tougher divisor. We're working with tougher factors when we're using inverse operations to find bigger, in this case, products when we're using inverse operations. So I can use the tape measure to help myself out and estimate. So I'm working with 6. I need to find out which quotient is going to get me where I need to be. So I'm trying to find 48. I know that my 0s, 5s, 10s, and obviously 2s, we don't need it on our tape, are our easiest numbers to work with. So 6 times 0 is always going to give me 0. 0 times any number is always going to give me 0. 6 times 5, I can easily find that out by skip counting by 5s, and I also know that when I'm working with 5s, that number is going to end with a 0 or a 5 every time. 6 times 5 is 30. Working with tens, even easier. I know I'm just tacking that 0. 6 times 1 is 6. I tack 0. Now, very important, this is where the tape can really help us out. I'm looking for 48. I don't know what the missing factor is. I don't know what the quotient is. I need to find out. So, by looking at the tape, I know that 48 falls between 30 and 60. 48 is much too big to fall between 0 and 30. So, I know that that missing factor, that quotient, is going to be between 5 and 10. I know that 48 is really close to 50. So, if I were to look for a number that's closest to 48, it's going to be somewhere in the middle here. So, let's try. I'm going to use my estimating skills. I'm going to try 7. 6 times 7 is going to give me 42. So I know 42 is less than 48, and I want to get to 48 as closest as I can. So let me also try 8. I know 6 times 8 rhymes and is 48. So this goes in evenly. 6 times 8 is indeed 48. We found our missing quotient. We found our missing factor when using inverse operations using the tape diagram. 48 divided by 6 is 8. Next step, I multiply 6 times 8. We found out is 48. I subtract 48 minus 48. 8 minus 8 is 0. 4 minus 4 is 0. I subtracted. I bring on down. I need to bring down my tens. I bring down that 6. I bring it on back. I need to divide. I'm asking myself, can 6 be divided by 6? Can 6 go into 6? It absolutely can. In my brain, I am thinking inverse operations when I'm dividing. 6 times what number is going to get me? 6? Absolutely is 1. I divided. I need to multiply. 6 times 1 is 6. I need to subtract. I subtract 6 from 6. I get 0. I need to bring on down. I have a 7 in my ones next. I bring that on down. I have a 7. I need to bring it on back. I need to divide. I'm asking myself, can 7 be divided by 6? Can 6 go into 7? It can, because I know 7 is a larger number than 6. So, in my brain, I am thinking 6 times what number is going to give me 7? Well, I know that 6 times 1, because it's a group of itself, is 6. That is just 1 less than 7. That's as close as I'm going to get. 1. I divided. I need to multiply. 6 times 1 is 6. I need to subtract. I subtract 6 from 7. I get 1. I need to bring on down. Oh, I got nothing to bring down, guys. What does that mean? I have a remainder of 1. 4,867 divided by 6 is 811, remainder 1. All right, guys, let's do another I do in standard form, working with tougher divisors. I now am working with a divisor that's a 9. So our problem is 7,843 divided by 9. I got my steps down. I got a tape measure ready to go. So starting off with dividing, I'm thinking to myself, can 7 be divided by 9? Or can 9 go into 7? Absolutely not. I know that because 7 is a smaller number than 9. I need to move over to my next place value. So, still dividing. I need to divide 78, or 7,800, divided by 9 into equal parts. So in my brain, I'm using inverse operations. I'm thinking 9 times what number is going to give me 78 or close to it. Again, working with a tougher divisor, a tougher factor, trying to find a quotient that maybe we're not as familiar with. So I'm going to go to my tape measure. I know I'm working with 9 as my factor, and I'm trying to find another factor to find my quotient. Find that missing factor to find my quotient, my partial quotient. So I know zeros, 5s, and 10s are easiest to work with. 9 times 0 is 0. 9 times 5 is 45. 5, 10, 15, 20, 25, 30, 35, 40. 45. 9 times 10. I know I'm working with 10. All I'm doing is tacking that 0. 9 times 1 is 9. Tacking that 0 is 90. So, trying to find a missing factor, a quotient, that is going to get me close to 78. So, looking at that 78, I see a 7 in my tens. I know it's going to be a much bigger number than a 4 in my tens, or a much bigger number than 45. 78, I know is close to 80. That's about here. So, I'm going to try a factor that's going to get me close to 90. I didn't mention it last time. Maybe if I don't know some of my factors, perhaps I can use a mental math strategy such as subtracting a group of 9 from this 90. Okay, I know that 90 minus 9, or one group less of 9, is going to be 81. 9 times 9 is going to give me 81. That number is still too big. It's bigger than 78. That will not work. That is not going to have equal groups into 78. It's going to have too many groups. 9 is too many groups of 9. It doesn't work. Okay, so I need to go to my next factor. I can subtract 9 again from my 81, or maybe in my brain I just know that 9 times 8 is 72. Now that's the closest we can get, guys. That's the closest we can get to 78 without going too large. So we found out it's 8. 9 times 8 isn't going to give me 78, but it's going to give me something close to it. It is going to give me 72. Working in the right place value here. I'm working in my hundreds. Got my 8 there. Found my first partial quotient using the tape measure. I need to multiply 8 times 9, 72. We found out. Okay, using our multiple strategies, not only inverse operations, but also the tape measure. I subtract. I multiplied. Need to subtract. Can I take 2 away from 8? Absolutely can. It's going to give me 6. 7 minus 7 is nothing. I need to bring it on down. Go into my next place value. Working in my tens. Got to bring down that 4. Oh boy. Working with another dividend that's tough. 64. So, might have to go to my tape measure again. Why not? Let me erase my estimates from before. Now I'm thinking in my brain using inverse operations. 64 divided by 9, that's like saying 9 times what number is going to get me 64 or a number close to it. I know 9 times 0 is 0. I know 9 times 5 is 45. Looking at the number I'm looking for, 64. I see a 6 in my tens. I know that's going to be much bigger, not much bigger. It's going to be bigger than 45. So, if I were to estimate where my 64 would land, it's about 20 more than 45 and about 20 less than 90. So it's pretty much going to be smack dab in the middle. So, a number between 5 and 10, I'm going to think 7. 9 times 7 is going to give me what? 63. Now, if I didn't have something to help me, I could have subtract 9 from my 90, just like last time. Subtract 2 groups of 9. 81. 72. And 63. Okay, 9 times 7 is going to give me 63. Whoop. That is 1 less than 64. That's as close as we're going to get. So, 7. I divided. I need to multiply. 9 times 7 is 63. I subtract. 3 minus 4 is 1. 6 minus 6 is nothing. I need to bring on down. I need to bring on down that ones place. I need to bring it on back. I'm dividing. 13 by 9. I'm thinking, can 9 go into 13? Absolutely can. 13 is a larger number. In my brain, I'm thinking 9 times what number is going to give me 13? Well, I know 9 times itself is going to give me 9. I know if I doubled that, 9 times 2 is like saying 9 plus 9. That's going to give me 18. 18 is too big. 18 is too big. I know that 9 can only go into 13 once evenly. I multiply. 9 times 1 is 9. I subtract. 13 minus 9. Can I take 9 away from 3? If I have 3, can I take away 9, guys? 1, 2, 3, 4, 5, 6, 7, 8, 9. I can't. I need to steal. Well, actually, technically I steal, and I still get 13. So I got to do a little math. 4. I have to now bring it on down. Do I have anything to bring it on down? I do not. That means I know it's a remainder. I have a remainder of 4. 7,843 divided by 9 is 871. Remainder of 4. I got 4 left over. All right, guys, moving on to partial quotient strategy. I said it right. Again, that's got to be like 5 in a row. Don't have any rules for partial quotient. That's what makes it awesome. But I do have some guidelines to help me. I want to chunk and subtract till I can't. I'm thinking big numbers, thinking numbers I know. And when I can't do that anymore, I know I'm adding my partial quotients and my remainder to find my final quotient. So, tape diagram is used a little bit differently when using partial quotient strategy. Instead of estimating to find missing factors or quotients, we're actually going to use it to help us chunk bigger numbers. And you're going to see that in just a second. All right, so I have 8,436 divided by 9 as my problem. I know I'm using partial quotient strategy. I need to draw my nifty line, help it separate. So I need to chunk and subtract. I need to think big. I need to work with numbers I know. I need to look at the numbers. Looking at the numbers, I see an 84. I don't see any 9s, so none of that's going to go in super evenly. 84, 43. 43 doesn't look too friendly knowing my 9s, but I do see 36. So I do know that 9 times 4 is 36. I just know that because I'm Mr. G. Maybe in my brain, I just know that. I was like, oh, look at those numbers. That looks pretty good. That's going to fit evenly. So I know that 9 times 4 is going to give me 36. I chunk that out. 9 times 4 is 36. I subtract it out. I know it's going to give me nothing in my 1s. I know it's going to give me nothing in my 10s because I chunked it out. I subtract 400s minus nothing, 8,000s minus nothing. I have my new dividend of 8,400. So I still have a really big number. I need to think big. I want to think all the way to my thousands place. I know that 9 can't go into 8 evenly. So here's what I'm going to suggest you guys do. I'm going to jump to this tape measure. So I want to think in the thousands place. So the biggest number I'm going to work with is 1,000. I know 1,000 is easy. I know 10, 100, 1,000, 10,000s are easy because I'm just tacking a 0. My divisor is 9. I know that 9 times 1,000 is going to give me 9,000. So this is what is going to help us chunk bigger numbers. Halfway between 0 and 1,000 is 500. So I'm working with big chunks, but I need to find numbers that make sense to me and that I can chunk out from my dividend here. So I know 9,000 is way too big to chunk out from 8,400. It's not going to work. So I want to chunk out something that maybe is a little less. I want to work with numbers that are friendly. So I move to my halfway point. Okay. I know I'm working with 500. It's still groups of 100. So I can multiply 9 times 5, which is what, guys? 9 times 5 is, count with me, 5, 10, 15, 20, 25, 30, 35, 40, 45. But I'm working with hundreds. I tack 2 zeros. 4,500. So I can chunk out 500 here and have 4,500. That is less than 8,400. Let's give it a shot. 500. Let's chunk out that 500. Nine times 500 is going to give me 4,500. 4,500. I subtract it out. 0 minus 0 is 0. 0 minus 0 is 0. Can I take 5 away from 4? I cannot. I need to steal. That 8,000s becomes 7,000s. I bring 10 hundreds over to my hundreds. 500s minus 400 is going to give me 900s. 4 minus 7 is 3. I now have a new number, a new dividend, 3,900. I look back at my tape. I still want to chunk big numbers. So let's take a look. I know my 2's are pretty easy. So I know that 9 times 5 or 9 times 500 is going to give me 4,500. Guys, that's too big for the dividend we have. We can't chunk 4,500 out again. It's going to be too much. So I need to chunk out a number that's a little smaller. I know my 2's are easy. I'm doubling, but I'm working with bigger numbers. I'm working with 200. Okay? So I know that 9 times 2 is like saying 9 doubled or 9 plus 9. I know 9 times 2 or 9 plus 9 is 18, but I'm working with hundreds. I'm working with 2 zeros. I am going to tack those things on there. 1800. Can I chunk out 1800 from 3900? Can I chunk out 1800 from 3900? Absolutely can. It is smaller. Let's do it. I chunk out that 200. 9 times 200 is going to give me 1800. I subtract it out. 0 minus 0, 0. 0 minus 0, 0. 8 minus 9 is going to give me a 1. 1 minus 3 is going to give me a 2. So, look at that. Can I chunk again? I can absolutely chunk again. I can chunk another 200 out of there. Let's do it. I'm then going to subtract out 1800 again. Guys, I'm running out of space again. I need to work big so you guys can see. So I'm going to have to, again, work over here. Start with my new dividend. You could do this too, guys, if you ended up running out of room. That's another reason to put the line there. Helps me organize my work, especially when I'm working with a lot of chunking. 2100. I had my 200. I chunk it out. 200 times 9 is going to give me 1800. I subtract it out. 0, 0. Can I subtract 8 from 1? I cannot. I need to steal 10 hundreds from my 1000. 8 minus 11 is 3. 1 minus 1 is nothing. 300 is now my dividend. I chunked it out down to 300. So, I'm still trying to think big, guys. I'm still trying to think big. So, I'm now only working in the hundreds place. Okay? So, I need to think numbers that are going to be friendly around not now 1,000, but 100. Ooh, look at that. All I needed to do was to get rid of those zeros, because I know I'm moving one place value to the left. So, looking to chunk out as close as I can to 300. I know that 9 times 100 is going to give me 900 because I am tacking 2 zeros. I know that 9 times 50 is like saying 9 times 5, tack a 0. That's going to give me 450. I know 9 times 2 is going to give me 18. 9 times 20, I tack 0. It's going to give me 180. I need to get a big chunk, that's a bigger chunk, not a super huge chunk, that's going to give me as close to 300 as I can. I know 9 times 50 is going to give me 450. Nope, that's too big. That is too big. What about if I did a 4, a 40? I know that 9 times 4 is 36. I tack a 0, 360. Still too big. I'm working with 300. Well, what is 3 going to give me? What is 30 going to give me? 9 times 30 is like saying 9 times 3, which is 27. I need to chunk out. I need to tack that 0, 270. So, I can chunk out 30. That's going to give me 270. That's going to make it a lot smaller. So, let's chunk out that 30. 9 times 30 is going to give me 270. I chunk it out. 0 minus 0 is 0. 7 minus 0 is 0. 2 minus 3 is going to give me what, guys? Oh, wait. Mr. G made a mistake. What mistake did I make? Can I subtract 7 from 0? Absolutely not. See, guys, we always make mistakes as mathematicians. I need to steal. You steal 10 tens. 7 tens minus 10 tens is going to give me 3 tens. 2 minus 2 is giving me nothing. I'm down to 30. 30 is my dividend. Really small number. I now can just think to my mental math strategies. I'm thinking 9 times what number is going to get me as close as I can to 30 or equally to 30? Well, I know that 9 times 5 is 45. And I know 9 times 2 is 18. So if I add 9 more to 18, that's like saying 9 times 3. I add 9 to 18. That's going to give me 27. That is awful close to 30. Let's chunk out that 3. 9 times 3 is 27. 30 minus 27 is going to give me 3. Can I chunk again, guys? Can I chunk 9 into a 3? Can I chunk that out? Can I divide 9 into 3? I cannot. 3 is a much smaller number than 9. I have a remainder of 3. I need to add partial quotients in the remainder. When I'm adding, I want to start with big numbers first. 500, 200, 200, 30, 3, and 4. Add them all together. Again, running out of space. Going to erase some of my work here. Nothing. 3 and 4. 3 ones plus 4 ones. Going to give me 7 ones. 3 tens plus no tens. Going to give me 3 tens. 2 and 2 make 4. Plus 5 more is going to give me 9. 937 is my quotient. I add my remainder of 3. 8,436 divided by 9 is 937 with a remainder of 3. Partial quotient strategy, I do. All right, guys, working into the second part of our lesson. The second step to our learning model is the we do. So you are working along with me. You're stopping or pausing me if needed to catch up. We are learning together step by step. I am not going to show you the tape measure for the we do for the sake of time. You're doing a great job. Stick with me. Yearn to learn. All right, partial quotient we do. Let's do it. We have 4,320 divided by 8. I need to think big when I'm chunking. So I'm chunking. I need to think big, work with numbers I know, look at the numbers and see if I can chunk something out evenly, perfectly evenly. So looking at my numbers, I see that I want to perhaps work big to start. I don't see any numbers that are equal to 8 there. So I'm going to have to work in my thousands place. So not working with my tape measure, okay? I know that 8 times 1,000 is going to give me 8,000. That's way too big. Let's try to chunk out half of that. So half of 8,000 is going to give me what, guys? 4,000. Is that what we're looking at? Absolutely. So in my brain or on the side, I'm going to think about chunking 8 times 500, which is half of 1,000. 8 times 500. So let's do this one together, guys. 8 times 500. 8 times 0 is going to give me 0. 8 times 0 is going to give me 0. What is 8 times 5 going to give us, guys? 5, 10, 15, 20, 25, 30, 35, 40. Look at that, guys. 4,000 right on the dot because I was thinking big, using numbers I know. I also could think of it this way. 8 times 5 is 40, tack 2 zeros, 4,000. Can we chunk 4,000 out of 320? Absolutely. It's going to give rid of all of our thousands. We'll see that in just a sec. I am chunking out how much? I'm chunking out 500. 8 times 500 gave us 4,000. Let's chunk that out. I forgot my line. Let's subtract together. 0 minus 0 is 0. 0 minus 2 is 2. 0 minus 3 is 3. 4 minus 4 is going to give me nothing. I need to ask myself, can 8 go into 320? Absolutely. Still have a new dividend. I regrouped and I need to continue to chunk. So, thinking big, looking at the numbers. You know what I just saw? I just saw a 32. I know my 8s pretty well, believe it or not. And I know that 32 is a product of 8 times 4, which is going to give me 32. But here's the thing, guys. My 32 is not in the tens and ones. My 32 is in the hundreds and the tens. So I have 32 in my hundreds and my tens. So when I'm working with bigger numbers and I see numbers I know, if I know that 8 times 4 is 32, then I know if I attack a 0, what's it going to give me, guys? What would 8 times 40 give me? I know I'm just tacking 0. 8 times 40 will give me 320. Holy smokes, look at that. We just chunked out all of this. So, I chunked out how much? 40, not 4. 40. 8 times 40 is 320. I subtract. 320 minus 320 is going to give me 0. Can I chunk 8 out of 0? Can I continue to chunk and subtract? I cannot. Do I have a remainder? I do not. I need to add the partial quotients and the remainders. Need to add 540. Not a very chunky problem. Why? We're able to look at the numbers and chunk really big. We made less chunks, but they were bigger and they were smarter. 0 plus 0 is 0. 4 plus 0 is 0. Whoa. 4 plus 0 is 4. 5 plus nothing is going to give me 5. 540 is our final quotient. 4,320 divided by 8 is 540. Working smarter with the numbers, getting better with chunking. Partial quotient we do. We do for standard form when I'm solving division with using the strategy of standard form. I need to do what first, guys? Always need to write down my steps. Say them with me. Not multiply. Divide. Multiply. subtract, bring it on down, and bring it on back. Working with tough divisors, let's go with 7 as our divisor, and let's go 6,839. Our problem is 6,839 divided by 7. I know I am dividing as my first step. Guys, where do I always start? What place value do I always start when I'm using standard form? The thousands. I'm thinking to myself, can I divide 7 into 6? Can 6 be divided by 7? The answer is no, because 6 is smaller than 7. It cannot go in equally. I need to move over to my hundreds. So, can I divide 68 by 7? Absolutely can. 7 can go into 68. 68 is a much larger number than 7. In my brain, I am thinking 7 times a number equals 68. At this point, you could use place value chart, tape measure I showed you, numbers you know. Let's start with numbers I know. I know that 7 times 10 is going to give me what, guys? What's 7 times 10 going to give me? 70, because 7 times 1 is 7, tack 0, 70. That is too much. 10 as a quotient is going to give me too much. I need to go one less. Let's try 7 times 9. I know that I can subtract 7 from 70 to figure out what 7 times 9 is. Let's subtract 7 from 70 together. 70, 69, 68, 67, 66, 65, 64, 63. I subtracted 1, 2, 3, 4, 5, 6, 7 to get 63. 7 times 9 is 63. Absolutely can do it. It is less than 68 and as close as I'm going to get. We divided, found it out we could divide 9. That's the closest we can get. I need to multiply. 9 times 7 is 63. Next step is what? I need to subtract. Subtract with me. 3 minus 8. Can I do it? Absolutely can. 8 minus 3 is 5. 6 minus 6 is going to give me nothing. I need to bring on down. What do I need to bring on down? I need to bring on down my tens. And then I need to bring it on back. So now I need to divide 7 into what, guys? I need to divide 7 into 53, which is my new dividend. It's actually 5,300, but we regrouped to work with a smaller dividend. So in my brain, I'm thinking 7 times what number? It's going to give me 53 or close to it. Working with numbers I know. I know my 5s. Guys, what is 7 times 5 going to give me? 35. That is quite a few less than 53. So I'll use a strategy. I use a place value chart. I use that tape measure. I know that 7 times 7 can give me 40. 49. That's awful close to 53. I can't go 7 times 8. That would give me 56. Too much. 7 times 7. 7 as my partial quotient is going to give me a close to 53 as I can. 7 times 7 is 49. I divided to get 7. I multiplied 7 times 7 to get 49. I'm subtracting I'm subtracting 49 from 53. I need to subtract 9 from 3. Guys, can I subtract 9 from 3? Absolutely cannot. If I have 3 and I subtract 9, if I have 3 and I subtract 9, here's my 0. 1, 2, 3. I already am 0. I have to take more away. I can't do it. I have to steal. I need to steal from my 10s. I need to steal a 10 from my 5 10s. My 5 10s becomes 4 10s. Carry my 10. 9 minus 13. 5 13. I take away 9. It's going to give me 4. 9 minus 13 is 4. 4 minus 4 is nothing. I subtracted. I need to bring on down. Let's bring on down this 9. Need to bring it on back. I need to divide. I need to divide 7 into 49. In my brain, I am thinking 7 times what number is going to give me 49? You guys should know. Why? Because we just solved it. 7 times 7 is 49. It goes in evenly. 7 times 7 is 49. I subtract out. What's 49 minus 49 going to give me? 0. I subtracted. I need to bring on down. Do I have anything to bring on down? What does that mean? I do not have a remainder. 7 goes into 6,839 equally. 6,839 divided by 7 is 977. Last step to our lesson, the you do. This is where you can work on all the skills independently, working on those learning targets. Your you do's. 531 divided by 9. 948 divided by 6. 7,423 divided by 7. 4,848 divided by 8. 5,231 divided by 9. Using standard form. Using partial quotient strategy. Using the strategies that I've been teaching. Do the you do, submit it to the flip grid. You're in to learn.